So in this section, we are going to be looking at a method for integration called the method of partial fractions. And this integration technique is used when we have some kind of rational function that is too complex to integrate by other means. This is for sure not the first. Like if you see a function you need to integrate, this is probably not the first one that you want to try. You might try, if it's a constant over a function, you might try just logarithm. You might try use substitution if it's something else. But when those don't work, the method of partial fractions is what you need to come down to. So in order to kind of set up what we're doing, let's go back to algebra. And so let's look at these two rational functions here. We're going to subtract these. And if you don't remember how to do this, we need a common denominator. And so our common denominator is just going to be the product of the denominators. So x minus 1 times x plus 2. And so we need to multiply the 2 by x plus 2 because that one's missing on this denominator. So 2 times x plus 2. And then minus, and then we need to multiply this numerator by x minus 1 because that one is missing in this denominator. So x minus 1. Now let's simplify. So we have 2x plus 4 minus x plus 1 on the top, and on the bottom we have x squared plus x minus 2. And then we simplify the numerator and we get x plus 5, and then on the bottom we get x squared plus x minus 2. So the idea here is we are going to learn how to do this starting here and moving to these. So we're going to learn how to separate these rational functions. And it's maybe something I think sometimes it's covered in pre-calculus, sometimes not. It just depends. So you may or may not have seen how to do this before, but we're gonna show you the different ways that we can do this. But first, let's see how this helps. So if we start with this function, as you can see, if we go backwards, this will split up into these two functions. So using the method of partial fractions, which we're going to learn, this is equal to the difference of these two over here. So 2 over x minus 1 minus 1 over x plus 2. And now these two are easy to integrate. We can integrate them separately, and 2 over x minus 1 just integrates to 2 times ln of the absolute value of x minus 1. And 1 over x plus 2 is ln of the absolute value of x plus 2, and then plus c. And so that's the idea. Once you get to here, the integration should be pretty easy for the most part. We may see some that get a little bit tricky, but nothing too bad, nothing we haven't seen before. Now the tricky part is always going to be getting from here to here, and so that's what we're going to start looking at. Now, before you do the method of partial fractions, you always need to make sure that the degree on bottom is bigger than the degree on top. So in this one, that is not the case. We have the degree 3 on top and degree 1 on bottom. So what you do in this case is you do long division. So long division, if you remember from algebra or pre-calculus, we need to write this, fill in the terms that are missing. So we need a 0x squared plus x plus 0. X goes into x cubed, x squared times. So if you remember, the way you decide what goes here is whatever you need to multiply this one times to get that. You could also think of it, we're dividing x into x cubed. So if you have x cubed divided by x, that equals x squared. So that's what goes there. Now, remember from long division, multiply. So we get x cubed minus x squared. And then we subtract. So this first one cancels. We have 0 plus x squared. So that gives us x squared plus x, and then plus 0. Just bring these down. X goes into x squared x times. So now multiply x times x minus 1. We get x squared minus x. Subtract. And then we get x plus x. So that's 2x plus 0. and then x goes into 2x twice. And then we multiply, we get 2x minus 2. Again, we subtract, and we get a remainder of 2. So now this becomes, so here's our quotient. So there's our quotient, and here is our remainder. So now we have the integral of x squared plus x plus 2 plus our remainder, 2, over the original denominator, x minus 1 dx. And now this should be pretty easy to integrate term by term. So integral of x squared is just 1/3 x cubed. Integral of x is 1/2 x squared, and then plus 2x, and then plus 2 ln absolute value of x minus 1, and then plus c. And there we go. Okay. So that one was pretty easy. We didn't do partial fractions with that. So whenever the degree on top is bigger, you need to divide first. And then if you have something, and then when you're with your remainder term, if you have something that now you still can't integrate, maybe then you need to do partial fractions, but always make sure to check that first. The next step is to factor q of x, which is your denominator, as far as possible. So for instance, if qx is x to the fourth minus 16, this is the difference of squares. So we can write this as x squared minus 4, x squared plus 4. Now x squared plus 4 will not factor any farther. X squared minus 4 is another difference of squares. So that will be x plus 2, x minus 2, and then times x squared plus 4. So I always make sure we are factoring these as much as possible. Okay, so step 1, you make sure that your degree in the denominator is bigger than the numerator. Step 2, we're going to factor the denominator as much as we can. And then next step is, now we're getting into the partial fractions. We're going to have 3 cases of these. So the case 1 is the denominator of q of x, f of x. I should say the denominator of f of x, but q of x, which is the denominator, is a product of distinct linear factors. So in other words, we have something like 1 over x minus 1, x plus 2, like we saw earlier. And then we can, when we have linear factors on bottom and they are distinct, then we can write this as a over the first one plus b over the second one. And then we'll see then we need to solve for a and b, which we'll see how to do in this one. Okay, so let's look at this one. All right, so first step, we see the degree on the bottom is bigger than the degree on top. So we can move to the next step, which is to factor the denominator. So x squared plus 2x minus 1. I don't think the numerator is ever going to factor for us. So don't worry about that. Just leave the numerator the way it is. And the only way that would matter is if you could cancel with something on the bottom, but that's not going to happen. I don't believe. All right, so let's factor out an x. So we get x times 2x squared plus 3x minus 2. We can factor this. X squared plus 2x minus 1, x. And then this will factor into 2x, what is it? 2x minus 1, x plus 2 dx. Okay, so now we have 3 linear factors. So now this, let's come over here. We'll just rewrite this. And so this is going to equal, we're going to separate these factors. So we have just like this. So we have a over x for the first one, plus b over 2x minus 1, plus c over x plus 2 dx. So now we need to figure out what a, b, and c are. there are two ways to do this. Whichever way you prefer, I think maybe the way I'm going to do this one is easier, provided you can solve a three variable linear system in your calculator. So three system of three equations can take a little while. I don't want you wasting time doing that. If you know how to do that in the calculator, you have a graphing calculator. It's pretty easy to do, but I'm not going to show you how to do that here. But if you can do it that way, then this way that I'm going to do this one is probably the easier way most of the time. I'm going to do another way on the next couple of problems, but let's look at how to do this in this way. So we're going to get a common denominator for this side. And we're kind of going to ignore the denominators, but we need to get common denominator first. So the common denominator is just the product of all these. So you're going to multiply A by whatever denominators you're missing, B by the denominators you're missing, and C, same thing. So we have A times 2x minus 1 times x plus 2 plus B times x plus 2 plus C times x times 2x minus 1. So we're just multiplying it by the ones that we are missing in whatever term we're looking at. Okay, so now what we're going to do is we're going to multiply all these out, and we're going to set whatever we have for our x squared term equal to 1. And whatever we have for our x term, once we multiply all these out, we'll set equal to 2. And then our constant term will be set to equal to 1. So let's see how that works out. So we have A times 2x squared plus 3x minus 2 plus B times x squared plus 2x plus C times 2x squared minus x. Okay, so now what we want to do is we want to gather all of the x squared terms together, all of the x terms together, and then the constant terms together. So we have, so let's do it right, x squared, we have 2a plus b plus 2c. So 2a plus b plus 2c for our x squared. All right, now let's get our x term. We have 3a plus 2b minus c. And then our constant term, which is just going to be minus 2a. Let's undo that. Minus 2a. So no constant term with b, no constant term with c. All right. So now we can set up a system. So we have 2a plus b plus 2c equals coefficient here, which is 1. Then for the x line, we have 3a plus 2b minus c equals 2. And then for the constant term, we have negative 2a, no b term, no c term, and that equals negative 1. Okay, so obviously we can see a equals 1/2, but I don't know if you've ever seen matrices, but it's easier to use matrices to solve these, or a matrix. So we're going to take the coefficients of these. And you want to make sure that your A's and your B's and your C's are lined up and they're equal to the coefficient or the constant. So let's write our coefficients. So we have 2, 1, 2, 1. So we're just grabbing the coefficients here. We're going to put this line, this is representing our equal sign. 3, 2, negative 1, 2. And then negative 2, 0, 0, negative 1. Okay, so now I would probably not recommend you spend time solving this by hand, although it might not be that bad because you know that a is 1/2, you can plug that in, and then you just have a 2x2 system, which is not terrible. But it's much easier if you can get your graphing calculator to do this. And so we end up getting, when we solve this, however you end up doing it, we get that A is 1/2, B is 1/5, and c is -1/10. So again, probably have learned how to do these in pre-calculus. May or may not have used matrices before. I'm going to show you a different method. If you don't like this, you can do this another way. There is another way to do it. So I'm just going to show you both ways. All right, so let's fill in our a, b, and c. So we end up with the integral of 1 over 2x. So there's our 1 over 1/2 divided by x, 1 over 2x, plus 1/5, so I have the 5 on bottom, 2x minus 1 over 1, and then minus 10 times x plus 2, like this. Okay, so we're substituting in a, b, and c over here. All right, so now we can integrate these. So this is going to be 1/2 ln of absolute value of x. Now this one, maybe you need to do u substitution. So let's come up here. Let's let u equal 2x minus 1 du is 1/2 dx. I'll let you fill in the details. We're going to end up with 1/10 ln 2x minus 1. So we've covered u substitution before. I won't go through all the details there. Then minus 1/10 ln x plus 2, and then plus c. And so there we go. So always make sure you put your absolute value around your ln argument. Don't forget your plus c. And as far, I mean, you can, obviously we got a 1/10, 1/10. You could combine these two ln's if you wanted, but not necessary. So we won't worry about that. Okay, so to kind of recap a little bit, first you want to make sure your denominator degree is the bigger one. If not, you need to do long division. Then you need to factor your denominator. So factor it completely. And if you end up with 2 linear factors or 3 linear factors, you're just going to do a over the first one plus b over the second one plus c over the third one. And then you're going to, in this case, we're going to find the common denominator and put all these under one term. Then simplify until we get an x squared term with coefficient of some combination of a, b, and c, an x term, some combination of a, b, and c, and then a constant term, some combination of a, b, and c. Then you can set up a system of equations and solve that however you know how to do. And then you plug in your a, b, and your c, and then it should be fairly easy to integrate after that. Okay, so next video we'll look at what happens when some of the linear factors are repeated, meaning they have like x plus 2 squared. What do you do in that case?